first law says that an object at rest remains at rest, and an object in motion remains in motion until an unbalanced force acts upon it. For instance, this object at rest will remain at rest until I kick it to Hirsch.
And the ball was in motion, and it was going to stay in motion until I stopped it, which I was the unbalanced force.
Yeah! Newton's second law says the acceleration of an object increases with increased force and decreases with decreased force. For example, when he pushes the skateboard with no weight on it, it'll go faster than when my weight's added to it, for example.
Now this time I'm going to push the board with Clayton's increased mass on it, and it should slow it down than it was before.
Yeah! Science rules! I'm slowing it down! Bob Saget! Newton's third law says with every action there's an equal and opposite reaction. In this case, the action throwing the basketball against the ground, the equal and opposite reaction would be bouncing it towards Hirsch, for example.
Bob Saget! Okay, now I'm going to explain what inertia is. Inertia is an object's resistance against motion. For instance, if I push this basketball, it's easier to push than Clayton. Clayton has more inertia than the basketball.
How does air resistance work, you may ask? It works by when an object's moving, it creates surface area. The air pushes up against that surface area and pulls it back or slows it down. Pretty much, it's friction with the air. For example,
when I throw this bag with a pen on it, the bag is going to make the pen fall slower than the pen it will. And now I can show you what the pen's like when I throw it alone.
because the air resistance would slow it down. Just like how I can run faster without this, because the air resistance would slow me down. And that's how air resistance